great to be with you. It's a nice, cozy audience. So I'm going to go through just some things at a high level to kind of set the stage, and then I think the most important thing would be that we have some time for some questions. Any questions that you have about what's been discussed today that I may be able to answer, any questions about some of the things that I provide in context here. I'm going to start by just giving you a very brief snapshot of the perspective from which I'm coming. FM Global, although we are an insurance company, we are really kind of a one-of-a-kind insurance company. First of all, we're only commercial industrial property. We don't do homeowners, personal lines, or any kind of automobile insurance. We're business-to-business entities, so we're not as well known as a lot of the Main Street insurers. We believe that the majority of loss can be prevented through research, which is my division's responsibility, and the engineering that we do to protect our clients that include 1 in 3 of the Fortune 1000 throughout the world. We are owned by those same clients, so we're one of the insurance companies that's still mutually owned. So everything we do is really to represent those clients, to keep them in business, to keep them employing people, and to keep them healthy and moving forward. It was mentioned our research campus in West Gloucester. I just came from there for meetings there earlier today. 1,600 acres where we do a lot of physical science research, fire, explosions, natural hazards. This is really where the solutions come from that we offer to our clients in terms of how to protect their businesses. We also have a facility in Norwood, Massachusetts that kind of includes the CSI of the commercial industrial property insurance world. Anything that breaks comes there. We have material scientists that look at those things. We also do our own climate analysis as well as fire physics, explosion calculations of that type. So we do scientific computing high levels there as well. 10 teraflop kind of scientific computing. So those are the two resources that we bring to bear. The company as a whole includes 5,000 people, 1,800 engineers, no actuaries. And I'll explain that in just a second. Our 39 offices worldwide are where our engineers report to, and they perform about 100,000 risk assessments a year of all of our clients' insured facilities. So our engineers will go into those facilities, they'll do a risk assessment, they'll provide a risk score according to our engineering, our research, our standards that we establish, and then that's what we use to underwrite. So we don't use actuarial tables, we actually use risk assessments to underwrite, which puts us in a very different position from the rest of the insurance world, but I'm certainly glad to talk to you about that. The three big trends that we're seeing, and I know a lot of these have been discussed, so I'm going to go through that very quickly. Obviously, we're at climate change. The notion that the climate is static is clearly not the case. We're in a very dynamic environment these days. You add to that the economic instability that is not just in Rhode Island or the U.S., but it's worldwide, and the increasing vulnerability to natural disasters. We continue to have businesses located in areas that are increasingly vulnerable. So the vulnerability is definitely increasing. So the question is, why can't we just model all this, determine how the climate's going to change and protect cases? Right? I mean, that's the simple solution. That's where we'd all like to be. If you look at the climate models from the International Panel on Climate Change, this is the kind of differences you see in terms of % increase in temperature trends for different regions of the world. And you see some of them actually predict the Atlantic is going to decrease in temperature. Some of them predict a drastic increase in temperature. So this is really one of the big challenges, is this climate of uncertainty that we're facing, including how to assess that dynamic situation of climate change. We know about how, when those climates materialize, how they affect Rhode Island. That's no secret to any of us in this room. But the problem is how they affect Rhode Island when they affect other parts of the world as well. Because our climate our environment from an economic perspective, from a business perspective, is very tightly coupled. We're no longer in an environment where Rhode Island is influenced by Rhode Island economics. Rhode Island is influenced by economics around the world. The globalization has led to this brittle system of interdependencies that businesses have and that we have as people that rely on those businesses as employers in our economic well-being. For example, Sandy, there's no other place in the United States where Sandy could have, in other words, one storm could have had such a pronounced effect on the gross domestic product that relates to the supply chain that all businesses rely on these days. If you look at the fraction of GDP that relates to supply chain that's affected by the region that was struck by Sandy, you have 17% of overall industry, 17% of wholesale trade, 14% of transportation and warehousing. You look at other focus points around the United States for GDP, you see California. California quake is not going to touch these kinds of numbers. Okay, so we have major hubs that affect global economics that these storms are affecting, and obviously that propagates throughout the economic system, it propagates throughout businesses, and we'll see how this one plays out in the next few days, or the next few months or even years as those effects take place. The overall trend actually becomes a little more problematic when you look at our current situation, where North America and Europe that are in the center with the high bars, the yellow bars are number of events, and the white bars are percentage of global economic losses. We see that we have, by comparison to Asia, a modest number of major events, but the majority of the losses, because this is where the majority of the economic world is centered for now. Okay? If we start to forecast out and move beyond 2009 into the future, what we expect we're going to see is about a 3 times increase in the economic impact once more of those vulnerabilities start to shift to Asia, given the percentage of natural disasters that are currently already happening in that part of the world. Okay, so this climate of globalization, if it stays on the same track, is going to continue to exacerbate economic impact for companies around the world. That's going to affect us here in Rhode Island. It's going to affect us around the United States. And it's going to affect really economic well-being in general. We already know this is happening because natural disasters for commercial industrial properties have exploded from less than 10 billion 15 years ago to over 110 billion last year. So we could definitely see the trend in terms of this increasing vulnerability. Okay, so now that I've given you this big doom and gloom picture, what do we need to do? Right? Well, first of all, it's obvious we need to assess what's really driving these risks. We need to make sure we understand it. We know hurricane risk is real. What's real confusing for a lot of business owners is how real is it for where I'm located. And the way the insurance industry manages these kinds of risks is they have different models that have different hurricane tracks. They run all these tracks and generate statistics and come up with a statistical probability for amount of loss. And the way that maps are run is they use even more tracks, and then they develop probabilities of exposure and hazards for our coastline. And the tracks shown on the left are the possible hurricane tracks from our collaboration with MIT that includes some expectations of the changing climate. So this is kind of where the science stands right now in terms of assessing hurricane risk. What we have right now is our 100 and 500 year levels. If we take a look at, this is coastal storm surge. Along the northeastern corridor, you see there's significant differences. Obviously, the water gets channeled in different ways as it strikes the coast. We take a look at Sandy. It's about 13, almost 14 feet. Battery Park in lower Manhattan, about 9.5 feet above the high tide. Obviously, it was influenced by the high tide at that point. About 4 feet above where Donna hit in 1960. Where this plays out is it's a little bit less than a 1% probability kind of event for that area. So if you look at that in years of return period, it's a little bit higher than a 100-year. So this is not what we would call a black swan or an unforeseen or kind of event that we look at and say, oh my God, we just can't imagine this ever would have happened. It's not outside of the realm of expectations by any means. Okay, so this is what we had to deal with. Obviously, given that that's what we know now and what we can start to assess, we've got to be able to reduce those exposures. How do we do that? Well, that includes for businesses protecting their property, protecting their operations, which relies on infrastructure. So it's great to hear the thinking that's going on to maintaining that infrastructure. The downstream effects are shareholder value. When businesses experience significant losses, their shareholders suffer, and businesses experience significant decrease in their reputation, including the reputation of an employer of choice when their businesses are affected by catastrophes. The important part about this slide is the first two are insurable. We can insure the property, we can insure their business interruption. We can't insure their shareholder value or their reputation. So that's where we're going to focus. But the real value in terms of turning people around to protect their property oftentimes is focused on the last two. A board of directors will realize that shareholder value, which they're trying to protect, means protecting property. And when they come to that realization, that turns out to be a much bigger stick than the notion of insurance premiums going up. Well, what happens? I recently toured the coastline after Hurricane Katrina struck. This is what some homeowners are doing there in terms of protecting their property. It's not very attractive, but it does come with free RV parking. It does provide that. For businesses, one of the things we're trying to do is have them realize that protecting property has a broader impact in terms of sustainability. We did a study on risk factors and how it affects carbon emissions over the lifetime of different industrial facilities. And if you reduce your risk by good established methods, you can actually reduce your carbon footprint by 2 to 14% if you're in a 100-year risk zone. Because you don't have to rebuild, you don't have to just, suffer through all the emissions associated with potentially a fire and all of those consequences. So why doesn't it happen? All right, seems pretty easy. Understand the hazards, protect against them. Well, the first is this uncertainty trap. Okay? We don't know exactly how the climate's changing, so we don't really know what to do, so we don't do anything. And this was mentioned by one of the previous speakers as well. This is a real challenge. Unless you can tell me exactly how things are going to change, I'm not sure I want to invest the money, especially for companies. So our guidance at this point is, first of all, identify those key exposures and protect them to the 0.2% or 500-year level as we know it now. That's the best we can offer. We're keeping an eye on how this changes. We're keeping an eye on the science. The expectation is that benchmark is going to change less than if we start looking at more frequently. And I'll take this opportunity to emphasize that we are starting to talk about percentages of probabilities for yearly occurrence rather than this notion of return period in years. So if you take a look at a 100-year storm, if you tell me I'm going to win the lottery every 100 years, I'll probably never play. But if you turn that around and use a different number to describe that same probability, which is I have a 1% chance of winning the lottery every year, I'll play, right? So we need to change how we communicate those hazards as well. The other reason is it costs. Obviously, there's a perception it costs a lot. We have some examples where it doesn't. Cost-effective protection of local floods. This was actually a great example from a hospital here in the Northeast. We had some other examples from earlier speakers. Just good design, good thinking, local flood protection. Wind cost, we showed during Hurricane Katrina that about half of our locations were improved according to our standards. Those improvements took less than $10,000 per location to achieve, and they suffered 85% less loss than unimproved locations. Just by fastening down roofs, locating those fasteners at the corner, attaching their flashing, pretty simple things, but they require a little foresight, they require a little retrofitting. Okay, so the last reason why it doesn't happen is really this notion that's already been discussed, is the notion of mindset. And obviously this plays into the uncertainty trap as well. If we take a look at companies, 96% of companies have operations exposed to natural disasters. Only 20% of those are very concerned about the impact on the bottom line. There's very much a focus on quarterly shareholder returns. So there's a long-term perspective that businesses are still developing in terms of how to deal with these disasters. We take a look at the employees that work at those companies, people like us, 75% of US-based workers don't feel their employer is well prepared for a natural disaster. And a little shy of 30% are only 30% or so are confident that their employer will have a job for them when disaster does strike. So this is a huge opportunity for businesses in terms of ways that they can improve their relationships with their employees. Or for those businesses that have made those preparations or do have those plans in place, the importance of communicating those plans to their employees. So how do we change the mindset? Well, we need to describe the risk in real terms, not math. 1% and 0.2% rather than 100 and 500. People are not very good at math. So this is a good way to maybe potentially reposition the way we talk about hazards. The second is really bringing disasters to life. What we know from working with Fortune 1000 companies is most of those companies will never face a catastrophe in any given year. The ones that do look at it very differently the next year. And we're in a position where the Northeast has experienced 2 storms. Now's a teachable moment in terms of bringing those disasters to life and thinking about what we need to do in terms of improving those risks or reducing those risks in the future. So just the 3 steps in terms of taking action. First of all, we've got to avoid this uncertainty trap. There's a tremendous amount of scientific uncertainty. A lot of research is going into that. Reinsurers have been very loud in terms of making the call for that research. Obviously, we support that research. That's going to take time. That's not the reason, or not a reason, to do nothing. Protecting to the 0.2% right now gets us out of that uncertainty trap. Defining cost-effective options. It's some of the things we're working on all the time. We put them in our loss prevention engineering standards. They're free and available online. We have FM-approved products, flood barriers, roof attachment, those kinds of things that are available for people to reference or be able to use on a cost-effective basis. So defining those and implementing those cost-effective options is really key. And then the third part is breaking through these kinds of barriers. And oftentimes this is where it starts. It starts in the boardroom or board of directors for major companies. It starts when employees come into their employer and talk about their concerns in terms of breaking through those barriers and looking for opportunities to reduce their risk.